Welcome to MRL. In this learning session, we'll be learning about rational expressions. An expression of the form px by qx, where px and qx are polynomials and qx is a non-zero polynomial, is a rational expression. Now, the conditions for any expression to be a rational expression, the conditions are px and qx are polynomials by definition. Px and qx are polynomials by definition. Every polynomial, any polynomial you take, it is a rational expression. Px and qx can have any number of terms, that is px and qx can have any number of terms, that means they can be monomials, binomials or trinomials, etc. Px and qx have their own degree. They can be a linear polynomial. Px and qx can be linear polynomials. They can be quadratic polynomials, cubic polynomials or polynomial of any degree n. And px and qx have their own zeros and factors. Remember that. Now, identifying rational expressions. If px by qx is a rational expression, the condition is that px is a polynomial, qx is a polynomial and qx is a non-zero polynomial. Remember that. If px or qx is not a polynomial, then px by qx is not a rational expression. For example, x square plus 3x plus 5 divided by x plus 2, we find that the px, that is x square plus 3x plus 5, is a polynomial, and x plus 2, that is qx, is also a polynomial, and therefore x square plus 3x plus 5 divided by x plus 2 is a rational expression. Now, if you see the second example, the px, that is x square plus 3 root x plus 7, is not a polynomial because root x is x raised to half, therefore it does not obey the definition of polynomial, and therefore px is not a polynomial. Therefore this is that is x square plus 3 root x plus 7 divided by x plus 1 is not a rational expression. Here in rational expressions, it is important for us to learn how to identify the polynomials and non-polynomials. Rational expression in lowest terms. The rational expression px by qx is in its lowest term if px and qx have a GCD of 1 or a common factor of 1, remember, or HCF of 1, remember that. Now, for example, 2x plus 5 divided by 3x minus 7, both px and qx have a common factor 1 and therefore they are in simplest form. Now, let us take one more example, x square minus 7x plus 10 divided by x square minus 3x minus 10. Now, we do not know whether they have a common factor or not, so we have to factorize that, factorize both px and qx. We can factorize by middle term splitting method. By middle term splitting method, I find out the factors of x square minus 7x plus 10 and x square minus 3x minus 10 as x minus 5 into x minus 2 and x minus 5 into x plus 2. X minus 5 cancels. It is x minus 2 divided by x plus 2, which is in the simplest form. So therefore, to find out the simplest form or the lowest terms of rational expressions, we have to carry out a factorization procedure, follow any of the methods of factorization and cancel out all the common factors and see that the GCD or the HCF between px and qx is 1, then that will be in the simplest form. So please remember how to find out the different how to carry out the factorization of polynomials and to express rational expressions in lowest terms. So it's very important for us to learn the different methods of factorization of polynomials to express a rational expression in its lowest terms. Remember that. Now, operations on rational expressions. Operations on rational expressions are similar to operations on rational numbers. Properties of rational expressions and rational numbers are alike. They are almost the same. Therefore, the closure property, commutative property, associative property, distributive property, additive identity, additive inverse, multiplicative identity, etc., which exists for rational numbers, also exist for rational expressions. Remember that. Now, let us, if you have to go for addition and subtraction of rational expressions, if px of qx, px by qx and rx by sx are rational expressions, then the addition is px by qx plus rx by sx. Taking the LCM, we get qx into sx, and therefore we have px into sx plus qx into rx divided by qx into sx, which is again a rational expression. Therefore, addition of rational expressions is a rational expression. So also subtraction of rational expressions is also a rational expressions, which I have shown here. Therefore, addition and subtraction of rational expressions is a rational expression. And remember, the addition properties and subtraction properties of rational numbers are also applicable to rational expressions. Multiplication of rational expressions, if we have px by qx as one rational expression, rx by sx is another rational expression, then multiplication of that will be multiplying the numerator polynomials and the denominator polynomials. We get again a rational expression. Therefore, multiplication of two rational expressions is again a rational expression. Again, remember, the properties of rational expressions and rational numbers are alike. Therefore, all the properties of multiplication of rational numbers are also applicable to rational expressions. Now, division of rational expressions. Now, if we have px by qx and rx by sx are rational expressions, two different rational expressions. Now, we have to divide the first rational expression by the second. That means division of px by qx divided by rx by sx is equal to px by qx into reciprocal of rx by sx, that is sx by rx, and follow the multiplication rule, that is px into sx, multiplying the numerator and multiplying the denominator and then simplifying it, we get again a rational expression. Therefore, division of two rational expressions is again a rational expression. So again, remember, the properties of rational expressions and rational numbers are alike, and therefore they exist and are true for rational expressions also. So please learn all the properties of rational numbers in detail so that they can be easily applied to rational expressions. So that is what is a simple study of rational expressions. I will be dealing with the calculations and I'll be and different examples as a different session of study. So remember these properties of rational expressions. Thank you.